Hi, everyone, and welcome to the eBPF and Cilium Office Hours live stream, also known as eCHO. Hopefully, you can hear me all okay. Do shout in the comments if there's any technical issues today. Fingers crossed there won't be. So it's great to be back on the eCHO live stream. We had a week off last week. Those of us from Isovalent were meeting each other in real life. So that was a really nice thing to do. We had a get together in Switzerland and another get together in California for those of us in Europe and America, respectively. So that's what we were doing last week. This week we're back, and I'll shortly be joined by our special guest, Marga Manterola. But before I get to that, let's have a quick look at some headlines. Actually, before I even do that, let's say hello to those of you who are watching us live on YouTube. Do say hello. I see Noel. I see Russell. Marga is already in the comments as well, so that's great. It's always good to know where you're joining us from. And of course, we welcome your questions and comments as we go through. Also, you might know we have our show notes. They're on HackMD. If you look down here somewhere, you'll find the URL on hackmd.io/@echo-live. And so if you at any point want to help us out by adding in a link, you can actually edit those live, which is kind of exciting. Let's have a look at what we have so far. So I've got 3 headlines right now. One is amazing news that Cilium has got over 9,000 stars on GitHub. GitHub stars are, they're not I don't know what kind of metric we'd call them. Some people call them a vanity metric. But obviously, it is lovely that 9,000 people out there have appreciated Cilium sufficiently that they've ticked that star box. So thank you to every one of the 9,046 of you who've done that. It's an exciting milestone for us. Very much looking forward to 10,000. The next headline that I wanted to show was the playlist from eBPF Summit. So if you go to our YouTube page, you'll find here all of the videos. We've got the full length videos from the 2 days of eBPF Summit, but we've also got all of the individual videos linked in here. So if you're looking for any of the talks, if you want to catch up or watch something again, you should find them all in that YouTube playlist. And the last link that I've got today is a post from the good folks at Trail of Bits. If you're familiar with the name Trail of Bits, they're the folks who did Kubernetes security audit and many other things as well. But I'm sure a lot of you from the Kubernetes world will be familiar with that security audit that they did for Kubernetes. So they've written a post. It's actually quite a nice walkthrough of writing an eBPF program, starting very much from the basics, a kind of, hello world type beginning, all the way through to a profiler for system calls. If you have any posts that you've been writing, any news that you want to share, one way you can get that to us is in the eBPF news channel in Slack. Hopefully you're all already members of the Slack channel. If you're not, shout and we'll get the link to Cilium and eBPF Slack posted in there. But yeah, do come and join the Slack channel. I'm definitely very keen to get your eBPF news. And if you've been creating content that you'd like us to share through eCHO, that channel is a great way to get it to us. All right, so just having a quick look at the comments. I see Chandra, hello, and I also see Noel saying GitHub stars are the new cloud native metric. I'm going to try something new here, see if I can show. There we go. It's like magic. We can show comments on the screen. So that's very cool. All right, so I think without further ado, we should move on to the main content of the day. So I would like to welcome to eCHO, and please everyone give a little emoji round of applause to Marga Manterola from Kinfolk. Welcome, Marga.
Hi, Liz.
Great
Thanks
to
for
have
having
you.
me here.
Well, thank you for joining us. So you are, I guess officially your job title is your Principal Engineering Manager at Microsoft now, because you were part of the team at Kinfolk, and then Kinfolk has become part of Microsoft fairly recently.
Yeah, that is correct. Yeah, it has been a very strange transition for a lot of us. At Kinfolk, we were proud to be the Kubernetes and Linux experts, and most of us never imagined ourselves being part of Microsoft. But yeah, it has been an interesting ride. We are now like kind of like the experts at Linux and open source. I mean, not the only, but like among a small group of experts of Linux and open source at Microsoft. And and yeah, Microsoft has shown that they are very keen on having a bigger presence in this ecosystem, and they are um, they want to have our contributions there.
Yeah, fantastic. Because the Kinfolk team have been known for quite a few years for their expertise in the kernel and doing lots of exciting things. Maybe you can tell us a little bit about what Kinfolk are focusing on now that you're in this new Microsoft world.
Sure, yeah. So we are mostly trying to continue what we were doing before. For example, with the Flatcar container Linux project, it's still going full steam ahead with a focus on growing the community and making the development of the operating system even more open than it was before. And well, from my team, the project that we are here to talk about is Inspektor Gadget. It was a project that before we didn't have that much time to spend on it, and now we can devote more time to it. So we're growing it, we're adding new features, and then yeah, we have a lot of interesting ideas for the time to come.
That's brilliant. And Inspector Gadget is a tool for Kubernetes debugging and using eBPF, right? So maybe tell us a little bit about the beginnings, how Inspector Gadget got created in the first place.
Sure. Yeah. So it was mostly created to fill a gap that we notice when you're debugging applications in Kubernetes. There's a bunch of things that are not the same as when you're debugging local applications, because like things run in containers in different nodes, and you need to figure out where the container is running. And if you want to run eBPF tools, and without a tool like Inspektor Gadget, you might need to like SSH into the node and then figure out the process ID of the container, and only then you can run the eBPF tool. And so Inspektor Gadget came to try to fill in this gap of making it easy to run eBPF tools that give you insight as to what's going on inside the cluster, and without any manual clunkiness, making it very easy for the user that just wants to get the information and doesn't have to like figure out what's the process ID of the container and that kind of stuff.
So I think some of the tools that are kind of part of Inspector Gadget, part of that toolkit, they're going to look pretty familiar to people who've used BCC. Some of the things like exec snoop and TCP top. What's the overlap between BCC and Inspector Gadget?
Sure, there's a lot of overlap because a lot of the gadgets that we ship are actually just wrappers around BCC. And so we have here an image, if we can. Yeah. Right. So in this slide, we can see like the gadgets that we are currently shipping. The ones that are in solid color are the ones in the release that is currently out, and the ones that are in white are coming up in the next week or the following week's release. And so the column on the right, you can see all the gadgets that are based on VCC tools. And on the left are the ones that we developed specifically for Inspektor Gadget. And we added the ones that we currently have from VCC were added because we needed them to debug something, to figure something out. But of course, if someone comes and says, "Oh, I would like to have this other VCC tool, which is super useful in this situation," it's really easy to add them because, as I said, it's just a wrapper around it. The magic of Inspektor Gadget is this matching the containers that you want to trace and then injecting the eBPF code for that. And yeah, and just like listing the gadgets, it's very easy.
So essentially, the Inspektor Gadget's sort of reason for existence is to connect an eBPF program to a Kubernetes pod. Is that about the right way of thinking about it?
Yeah. That's the gist of it. Yes. So yeah. So let's talk a little bit about how it works. So it has basically two parts. On the one side is what we run like in our laptop or workstation or whatever, which is a kubectl plugin. And this connects to the Kubernetes control plane that can be running wherever. And in each of the nodes of the Kubernetes cluster, there's going to be a gadget pod that takes care of installing the BPF code into the kernel of that node. And so these are like the two parts of Inspektor Gadget. One is like the local plugin, and the other is the one that's running on the cluster. And the what I was saying about like how it can match the containers, it can match the containers for different kinds of selectors like labels, namespaces, names of pod, like all the usual Kubernetes, I don't know, the kubectl way of interacting with containers. And how it does this is through like the main piece of Inspektor Gadget is this Gadget Tracer Manager, which is the piece that keeps track of when containers get created, when tracers get created. So using OCI hooks, if they are available, and other methods if you're using a different container runtime, the Gadget Tracer Manager keeps track of containers that come and go. And then when we execute the kubectl plugin, it adds or removes tracers. And then this gets stored in a BPF map. So whenever we want to run BPF code, the BPF code doesn't know anything about namespaces, pod names, or any labels or selectors. The BPF code just looks at the BPF map and sees what are the processes that need to be traced because they are in the map. And all of the other work is done by the Gadget Tracer Manager that says, okay, this container matches this label, so it should be in the map, and this one doesn't match the label, so it shouldn't be in the map.
So that Gadget Tracer Manager needs to be installed. You've got the daemon set that needs to be in place before any pods and containers within those pods that you're going to debug.
Right. Yeah, exactly. Yeah. It needs to be deployed into the nodes. And yeah, it needs to be done before. And once you have that, you can do all the tracing you want.
That makes a lot of sense. All right. I think we should try and see this in action. Does that sound good to people?
Yeah, let's do a demo. Okay, so the first thing we're going to do is install it. And so I'm going to get rid of the slides. And so there are a couple of ways we can install it. You can like just download it from GitHub, but I'm going to install it with Crew. So
Crew is great. If people haven't come across it before, it's like a kind of plug-in manager for kube control, and yeah, it's makes things so easy to install new extensions.
Right. So it's very easy to install it with Crew. Of course, you can use other methods if you prefer, but I've gone with Crew, and so now I have the Gadget plugin installed. And as the screen is telling me, like now it's telling me it needs to be deployed on each node with this command. So first I just want to show that I'm running a Minikube cluster that I created specifically for this demo. But this can run on basically any Kubernetes cluster that where the nodes have kernel headers or similar mechanisms for you to run eBPF. And we can talk a little bit about other ways of running BPF code later. But for now, there's this caveat is you need to have kernel headers on the node. Otherwise, it's not possible to run BPF code. All right, so I'm going to install this, but because I'm a little bit paranoid, instead of just applying it, I'm going to first look at what this does. So
never run code directly from the internet, kids.
Right. So we can see that it's very straightforward. It creates a service account. It creates a cluster role binding, and then down here there's a daemon set, and this is like the daemon set that we were talking about. That it creates this pod that it's called Gadget, that it has this Gadget label, and it downloads this the Gadget container that Kinfolk publishes. All right, so now I'm going to actually apply it. So that seems to have gone fine. All right, so this is creating. It takes a little bit. It has to download the container, start it, but it's usually pretty quick.
Okay. Maybe while we wait for that to come, we'll take a question. So I'm going to do this magic thing of bringing it on the screen. Birdboat asking whether there's merit to making newer BPF programs aware of namespaces. I assume I don't even know if that question means container namespaces or Kubernetes namespaces. I'm going to guess the latter.
Yeah, I'm guessing also it's Kubernetes namespaces, and in that case, I don't know. I think it's mixing layers in a way that's probably not useful. Like when you are writing a BPF program, you are writing in C in a very low level way, and all this like Kubernetes stuff usually happens like in a different layer. And yeah, I mean,
okay, we got clarification. Birdboat was meaning Linux namespaces.
Linux namespaces, huh? So I mean, we do use, for example, mount namespaces for matching the containers with stuff. We actually use mount namespaces. So maybe we are already doing what you're suggesting, but yeah, I think it depends on each program and what it does. Yeah, depending on what is the use case, you might want to take into account something or another. For one of the new gadgets that we are working on, we are actually taking into account the network namespace. So yeah, depending on the context, there's different namespaces that come into play.
Yeah, and I guess normally a BPF program has the context of the process that it's related to, and then from the process you can find the namespaces that process is part of. So yeah.
Yeah. All right. This is definitely running now. Let me see what I wanted to show here. We can look at the logs. So just to see that everything is running correctly. And in this case, we only have one, but like this command would work. Like if we had 3 nodes, we could get the logs for all the 3 gadgets this way. And yeah, it basically says that everything is running. So we are ready to do some gadgeting. All right. Before we add any workloads to the cluster, I think it's interesting to just like observe what's going on in the cluster, just like with no workload. So we can run an open snoop in all the namespaces and see if there are any files getting opened. Right. So like etcd is doing stuff. And I think if we wait a few more seconds, there should be more liveness probes or something. Right. IP tables is also doing stuff. So I always find it interesting that like this is a cluster that is not doing anything, but even though it's not doing anything, there are processes and they are doing stuff. We can do the same with exec-snoop and see what binaries are getting executed. Yeah, we already saw that it was IP tables and it's probably going to be etcd. Yeah, okay. I guess the liveness probes and whatever are not that often. So it's a little bit random when we get anything. But yeah, I thought we would get something else. And it's interesting when I stop it, I also see things happening, and these things happening are happening in the gadget pod. And because I'm tracing everything, I'm like the gadget pod is tracing itself, right? And so like these are the like when it finished executing, like it stopped the BCC wrapper, and we see it stopping, and then it finishes. Anyway, let's do one more, and then we can add some workloads. So Tcp Tracer is another one that shows us TCP connections, like the accept and connect and so on. And so the same thing as before, right? Like there's a lot of TCP connections going on, and there's a lot of core DNS because the pods are talking to each other and are asking core DNS all the time. Like, okay, so what's this pod and what's this other pod? And yeah, I don't know. I think it's interesting that all these DNS queries are going on inside the cluster. Why is it
even
not
when
cached?
nothing is happening? Yeah, yeah. And it comes back to, we had Laurent Bernay on quite a few, maybe a couple of months ago on eCHO, and he was talking about, you know, how many DNS queries you get because of the way Kubernetes looks for kind of a service at different levels. So it's look for a kind of local service, and it'll look for a, you know, service in the same namespace, then in the same cluster, and eventually go and look for an external name. So you can quite easily end up with, I don't know, half a dozen different DNS queries just to resolve one thing. Yeah, so if folks didn't already see that episode about DNS, check it out. So
all right. Okay. So yeah, but this was just like to see what the cluster is doing when nothing is going on. But of course, we want to put some actual workloads. First, we'll start with just a simple Ubuntu pod that we can execute commands in, so we can see what happens. So I'm just going to run Ubuntu in a pod called Ubuntu. All right. Okay, so that's running there, and I have another terminal here where I can, oh, yeah, okay. I can do pod name Ubuntu. So this time, instead of running for all that was going on, let's just do exec-snoop for that one. Yeah. Oh, like this. No? Okay. I thought I had already sized this correctly, but no. All right. So, I can like execute stuff. Some fun things that you can try. No, I don't know, not fun specifically, but something interesting is that like if you call echo, this will not execute anything because echo is part of bash, and then xxsnoop only catches execution calls that call a different process. So it's something to keep in mind. Like if you are using these tools, you need to understand how they work, right? It's not like each thing that runs will trigger a call in xxsnoop. It's only when it's executing a separate process.
Mm-hmm.
And right, let's do an open snoop. And so if I do the same thing as before, I see that just to execute the ls, like it opens all of these files because it has to load all the libraries. And similarly to execute ps, it opens a lot of different files. And yeah, as I was saying, like I think it's important for anybody that's trying to use these tools to understand what it will say, because like if you don't understand the tools, then it's like it's not going to give you any insights. And let's show TCP Tracer. And then if I do like update, right, we see that uh, it created a couple of connections to like do the update. And then if I like install wget, and then there's another connection for the download. So with TCP Tracer, we can see the different connections that it's doing to which IP, to which port. We do not see the contents of the connection. For something like that, you would need to use a different tool. Do we have any questions, any comments that we want to cover?
I think going back to the namespace point, Christopher pointed out that there are some namespace aware BPF helpers in the more recent kernels, but yeah, as Christopher goes on to say, there might be they might not be available in all sort of widely distributed kernels yet. So
yeah, so that's an issue with BPF, because like during the BPF summit, there was a talk where they were saying, okay, because we have BPF, I mean, like it's one of the things that we always talk about with BPF. We have BPF in the kernel, we can create the code that we want without having to change the kernel. But there's been a lot of developments in BPF in the last few kernel versions. And so if we want to make use of like the latest BPF features, that means we are leaving out a lot of previous kernels, right? Mm-hmm. And so there's a balancing there of like it's super cool to make use of the latest features that give us like a lot of extra functionality. But if we do that, then only people that are running 5.10 or higher can get access to that. That's an example. But and then like anybody that's running like an older kernel because they are on a long-term support version or whatever, they won't have access to that feature. So it's a balancing act of like making use of the latest features versus making it available to the most people.
Yeah, for sure. And I guess one of the really exciting things about eBPF now is that at least some of the kind of basic functionality is now very widely distributed. So we can, start to see eBPF really getting used. in the real world now. It's not just limited to sort of experimental distributions anymore.
Yeah. All right. I wanted to show one more thing. So in this case, like I started the Ubuntu pod and then I started tracing it. But I want to show how I'll leave this pod here. I'm not in the Ubuntu pod anymore. And I'll start to trace for a pod named Ubuntu 2. So right now there's no Ubuntu 2. Right? There's only Ubuntu. There's no Ubuntu 2, but I can start an Ubuntu 2 pod. And then when I do an exec, it gets traced, because this is like what I was explaining earlier about the Gadget Tracer Manager catching containers that get created or pods that match the labels. So when I did the exec snoop, nothing matched. But then there was a pod created with this name, and the Tracer Manager matched it and added the ID to the map so that the exec snoop would find it and would be able to trace it. And so this here is just like a toy example, but this allows us to say, okay, I want to trace any pods that match this selection criteria, and the trace will be able to trace them regardless of the pods existing now or not. So
if you had
I think that's pretty cool.
Scaling dynamically, you'd be able to collect all the traces for however many instances there were.
Right. Yeah.
At that time. Yeah.
In the future. Yeah. I think that's really cool. All right. So that was the toy example. Now I want to show a different example.
I was going to say hi to Roland, who said he likes that it traces future parts. Hi, Roland.
Yeah. Yeah, it's really cool. All right. So Inspektor Gadget has this like debugging capabilities, but it's not the only thing that it has. It also has advising capabilities. And so one of the advisors that it has is regarding network policies. And what it does is it captures traffic and then creates, based on this traffic, it creates a basic network policy YAML that one can go afterwards and edit. It's not intended to be like applied as is, but it helps create a network policy YAML when there isn't one. And it also helps understand what's going on. So to see this in action, I'm going to use an example from Google that's called the Online Boutique. It's an example that is useful to showcase Kubernetes because it has like, I think, 10 microservices that are talking to each other. It's very complex and it doesn't have a network policy. So I'm going to quickly show this file just to like give you a quick look of the things that it has. Like it has a bunch of different services that like they talk to each other in different ways. They have health pros, and yeah, so they connect to different things, and it's very complex and it doesn't have a network policy. So right, so one important thing when we are doing this is that we want to capture all of the traffic. And in order to capture all of the traffic, we need to start Inspektor Gadget before we start the traffic, because otherwise some traffic might get lost if we start it later. So the first thing we are going to do is to start the network policy in monitor mode. So yeah, I'll do it in the other terminal. So here, I'm going to start network policy monitor, and I'm going to do it for the demo namespace and store it in a file called mylog.json. All right. Okay, so this is now logging. There's nothing going on yet, but as soon as I start putting traffic, it will start logging. So now I'm going to apply this YAML file that I showed in the demo namespace. Oops. Oh, I forgot to create the namespace first. Okay. All right, so this created all of the things. Let's just have a look at my log and see. Oops. Maybe I needed to create the namespace before I started the thing. Let's see if the pods are creating. Maybe they are not generating any traffic yet. So
yeah, it looks like
let's give it a second, and if there's still nothing in the log, I'll start all over. Okay. Yeah. Okay. So the log is getting things. So good. That means it's working. And while the containers are creating, we can also like do some. We can look at them with Gadget as well. So we can do something like what we were doing before. XX snoop in the demo namespace. Because we need to wait a little bit until like everything comes up and eventual consistency and all of that. But we see that there are some health probes going on and some Python is executing. And yeah, eventually, like it takes a while until everything is up. But it looks like it's coming up nicely.
So they've got a few different language implementations in this sample app with some Python. I've seen some Node.
Yeah, probably some Go as well. The card service is probably Go.
Oh, it could be, couldn't it? Yeah.
Let's see if we have it up by now. You are still coming up, but almost there. It takes a few minutes. Yeah, but I can show the log again just to give an idea of the kind of things that are getting logged. It's kind of similar to the TCP Tracer output, not the output, but the content. So like it has the type of event that it logged, the port, the labels involved. So like what was the pod name and the pod labels. And then it should have like source and destination, or yeah. So what it was connecting to. So there's the accept, there's also the connect, and so like it logs all these connections, and then afterwards we will see how we can run a report command that process all of this information, because this is obviously not nice for humans. This is just for machines. It processes all of this information and creates like the recommended network policy. All right, we're almost there. Only 2 are crashing.
Maybe they're not that serious.
Yeah, I guess if the front end is already up, we can at least like open the web page. So yes. So if I copy this link and then go to the browser here, no, not this one, here. Right, okay, so the website, like it's working, but maybe if I click this, it will not work yet. So, because it's not fully up, but it's half up. But I think we have enough traffic to have a look at the network policy. Of course, if we were doing this for real, we would capture more traffic. We would make sure that it has like actual user interactions and like all the relevant interactions are captured. But yeah, for now, for this demo, I think we have enough. And so we can stop the monitor and now call, let's call report and then give it the input file. And then this will generate a YAML file. Maybe I open it here. Or yeah, maybe with Vim it's nicer. All right, so here we have the network policy that was generated, and we can see how like these connections that we saw get turned into suggested network policies, where we see that like for each of the different services, right? Like this is like the service, and this is the network policy associated with the service. It says like, okay, like for this egress port that goes to this service and this egress port that goes to this other service. And so like it knows which service is in which port and suggests that this is the policy that you might want to apply in your cluster.
That's pretty cool. I don't know if you're familiar with it. There's a Cilium network policy editor, and I'm thinking it would be really cool to take the generated policies, load them into the policy editor, and then you'd be able to see visually what kind of policies those would reveal, which would be quite cool. But we can do that another time, or we can leave that as an exercise for the audience. We did get a question, well, actually a comment. Let's take this comment from Roland first, about, so you can start a workload without any policy, it runs for a while, we automatically get a policy generated, which I think is exactly what we've just seen, right?
Yeah, it's pretty cool, but always the caveat that you shouldn't just use this as is, right? You should look at it and see if it makes sense for your workload, and that like you're not just like randomly applying something, but yeah, that's exactly what this is, and yeah, it's quite cool.
One little gotcha that people quite often miss out of network policies is allowing the DNS requests. So I'm intrigued to see whether or not there's anything generated there for like port 53. Probably.
This is just for TCP, and I don't think it has any 53. No, I don't think there's anything about 53 here.
Okay.
We might need to like check that out.
It's a common gotcha, I think, for network policies, for people to create a policy, have default egress deny, and then wonder why their app can't actually find any services, and it's because it can't issue any DNS requests. So yeah, that's cool. Andy also, hi Andy, making the comment that the Cilium editor has a capability as well. So yeah, you can upload flows collected by Cilium, and you can upload those into the network policy editor, and it will generate an appropriate policy that way as well. I guess this would work regardless of your CNI. The Cilium network policy assumes or network policy generator assumes you're using Cilium to collect those flows. Yeah, but this is very cool. I'm just going to show Chandra's comment here. I am mesmerized. That's really cool.
All right, but there was another question that I thought it was that we wanted to go, like why is the recommendation service failing,
Yes,
right?
yes. So Russell was suggesting, could we use Gadget to debug why the recommendation service isn't starting?
Yeah. So yeah, I'm not going to spoil the the outcome here, but we can try. So so first let's have a look at what's going on. So let's describe this pod here. And so we see that it's getting killed because the liveness probe failed, right? And sometimes the liveness probe, sometimes the readiness probe are failing. And one thing that Gadget has that it's another cool thing is it's a gadget called Trace Loop that keeps traces kind of like S trace, but they are always there in a ring buffer. So it's always capturing syscall traces, but it doesn't add that much time. Like, if you run something with S trace, it becomes really slow. And that's because it's only storing the traces, the syscall traces, but it's not accessing them. So it's very minimal, the time that it adds. But the cool thing is that when something fails, we have the information of why it failed, because with strace, you need to run strace before the thing fails, and only then you can see what's going on. With trace loop, it's always there. So let's look at TL gadget trace loop list. Let's see the list of traces that we have in the demo namespace. Oh, okay. This doesn't fit my screen. All right. So I have the font is big, so it doesn't fit the screen, but we can see that there are a bunch of traces. And here in the status, we see this was terminated 7 minutes ago, 654, and this one was started 4 minutes ago. So the one that says started, it means it's still running, and all the others were killed. So we see that the ad service got killed 3 times, and then, or got killed 4 times, and then the 5th time it managed to keep running. But the recommendation service, like, it's been trying to run for a few minutes and it's still not running. Well, I mean, it's running, but it probably will die again because, like, it's died so many times. So what we can do now is look at, like, the latest trace that died with trace loop show and then the trace ID. So this identifier is the identifier of the trace ID. And let's do it with less. So just to make it clear, what I'm looking at here is the trace of a container that already died and was replaced by another one. So usually we would not be able to look at that, like we would not be able to look at anything related to the container because it has already been replaced by another one. But here we can see all the system calls that were done. Well, not really all of them, because this is a ring buffer. So at some point, like, it overwrites itself. There's only a limited amount of calls that can fit there, but we can see a few and we can, like, go to the end. So now I'm at the end and we can try to figure out what's going on. And it's not easy to figure out what's going on, but we can, like, look at the system calls and see if we find anything obvious. We can see that there was some Python program getting executed, and then these are, like, the gRPC liveness and readiness probes that are getting executed in between the Python program. So if we go up, we see that they are happening in between. And if I keep going up, we see that this Python program here was waiting on something, and then the liveness probe started, or that, like, the next liveness probe started. So this one timed out and then another one started. So I guess it's not that cool But the reason why this is failing is this is running on a Minikube on my laptop, and the service is actually quite heavy. So it just it doesn't manage to come up completely, and the liveness probe kills it. Like if we made the liveness probe longer, like if we allowed it more time to come up, eventually it would come up. But what we can see here is that the program was executing fine. It didn't really like encounter any fatal errors. It was just like waiting, and then the gRPC call came, and then here it just killed it. And
so
that's what happened.
Noel suggesting you could use a similar thing to see which config files an app was trying to use, and presumably if it then failed to start because the config wasn't correct.
Actually, this is one of the demos that we've done in the past, was like have an Nginx that was incorrectly configured and use this trace loop to find out like which file it was accessing and like fixing the path so that we could correct it and make it come up. But in this case, unfortunately, it's not something that we can actually fix. It just needs patience or a larger deployment of Minikube.
Joaquim's mentioned that there's a plugin for this in Headlamp, and I think Headlamp is another Kinfolk project. Is that right?
Yeah, that's right. So Headlamp is a web UI that connects with Kubernetes and has plugins for Inspektor Gadget. And actually, that's one of the things that we're working on lately, which is adding better interaction, because right now for using Inspektor Gadget, you need to run like this kubectl plugin. And for a human running it on the console, it's nice. But for like another program that wants to interact with it, it needs to like parse output, and that's not so nice. And so we've added a CRD that allows applications like Headlamp to tell Inspektor Gadget, I want to see these trays, and then Inspektor Gadget can give the output in different ways, like through a file or through a gRPC call, or different ways depending on what the application wants. And so this is coming up in like the next releases, because we also wanted to make it easier to integrate with other applications like Headlamp.
So now that we're talking about future releases, what other things are coming up in the future for Inspektor Gadget?
Yeah, so as I said earlier, we have a lot of ideas, a lot of things that we want to explore, and one of the things that we've been working on is adding BTF support, so that with BTF support, the necessity of kernel headers goes down. Of course, we still want to keep the old support. So like if you have a kernel that doesn't have BTF support, but you do have the kernel headers, you can still run the code like you did before. But now you don't need the headers anymore. You just need BTF enabled in the kernel. And with that, we've also been exploring other things. Like there's this cool project called BTF Hub that has the BTF symbols for a lot of kernels, even kernels that didn't have BTF support, but for different distributions. So we can say, okay, you are running this Fedora version or this Ubuntu version. It doesn't have BTF enabled, but the symbols are in BTF Hub. We can download them from there, and then we have BTF support. And taking this even further, our colleague Kevin Sheldrake from Microsoft, he gave a talk at the eBPF Summit about this, which is quite cool, where he talked about inferring the symbols from the running kernel. Like even if you don't have BTF, you don't have kernel headers, you don't have anything, but you can infer the symbols from the running kernel. So we've been exploring all of these things and trying to figure out like how we can make it easier to run tools like Inspektor Gadget anywhere, even though if you don't have kernel headers, you don't have BTF support, but you want to run it in your cluster, right? And up to now, it's been like the main blocker for using eBPF tools, that you need to have the headers, or like lately you need to have BTF enabled. And I think like this is like the next big thing, is making it less necessary to have all of this.
Yeah, Kev's talk is really cool, and I've linked to it in the show notes because it's really cool the way it does this like live inference of the structure. So it kind of takes a structure that it knows, or it knows what the data should be, or it makes a BPF program run where it knows what some of those contextual contents of the structure should be, and then it looks at the contents of the structure and says, well, I don't know, the process ID has got to be in here somewhere, and I know what the process ID is, so I can look in the structure until I find that matching field, and it's really cool. So definitely check out that video, folks. That's great. So I mean, there's quite a few gadgets already in existence, and you showed us a few more that are coming down the pipeline for future releases. What should somebody do if they've got an idea for another gadget that they think would be cool to add?
Right. So our repo is in GitHub, and so we welcome feature requests, bug reports, and of course pull requests. Adding BCC tools is super easy because it's just a wrapper. So it's something that, like, if there's a VCC tool that you really want to run in your cluster and you just want to add a wrapper, it's like super easy. You can just go ahead and do it. And if you want to add like a custom gadget that's more complex, that's going to take more work. But we are, of course, very happy to work together, collaborate with anybody that wants to participate.
Brilliant. So we're pretty much getting to the end of the time. I'm just going to bring up Russell's comment, which I'm sure speaks for several people, how this is cool. So yeah, thank you so much, Marga, for coming on the show, giving us some amazing demos. I think that was really, really powerful. I love a demo. I think everyone loves a demo. So that was really great. If anybody's got any last minute questions, type them in really, really fast. Just seen one come in. Is there a project in Cilium to monitor the file system? So there is some work that is going on in Cilium. We've shown a slide once or twice looking at how it's kind of upcoming features, but we have shown how we can use the knowledge that we get from the context of BPF calls to sort of map what executable has initiated a particular network connection and what files are being opened and so on. So there's something coming in that direction, I would say. So thank you for the question, Dinakaran. Thank you so much, everyone who's been watching. Next week, we should be back to the US time slot, which is, I think, 5 hours later on in the day with Duffy. So it just remains me to say thanks once again to Marga and wish everyone a brilliant weekend.
Thank you, Liz.
Bye, everyone.